When you install an industrial gate valve, you are trusting it to isolate massive amounts of fluid pressure. Sourcing the wrong specification or relying on a supplier with inconsistent quality control leads directly to system failure, ruptured joints, and expensive facility downtime. To prevent that, we are going to build a finalized technical specification sheet and a strict vetting checklist so you can confidently evaluate overseas manufacturers. Before you can build that spec, you need to measure 4 parameters at your installation site: the specific fluid type, the maximum operating pressure, the maximum temperature, and the exact pipeline diameter. You also need to follow one absolute operating rule. Gate valves are built exclusively for full flow isolation. They must be completely open or completely closed. If you use them to throttle flow, the fluid velocity will vibrate the gate and cause severe internal damage. If you do not have your exact operating conditions mapped out, and if you plan to use the valve for anything other than isolation, any purchasing decision is a financial liability. Step 1 is evaluating the specific fluid flowing through your system to determine the correct internal gate design. For clean fluids, specify a wedge gate. It moves vertically against inclined surfaces for a tight seal. For high pressure, a parallel gate uses flat discs, allowing fluid pressure to reinforce the seal. For slurries, a knife gate uses a sharp blade to cut solid obstructions. The physical properties of your fluid dictate the internal geometry you select. A mismatch here guarantees that the valve will fail to seal. Step 2 is choosing your external stem configuration based on your physical installation space and your maintenance access. In a rising stem configuration, the stem travels upward as the valve opens. This vertical movement requires significant overhead clearance above the pipeline. The advantage of this clearance requirement is that it gives you immediate visual confirmation of the valve's open or closed position and provides easy access to the external threads for routine lubrication. In contrast, a non-rising stem rotates completely internally to open the gate. This saves critical installation space in tight environments, but it means you cannot determine the valve's position just by looking at it. Your layout decides this configuration for you. Select the rising stem if you have the space, and prioritize maintenance visibility, and use the non-rising stem if your spatial footprint is cramped. Step 3 is specifying the valve body material based on your maximum operating thresholds, specifically targeting temperatures up to 180 degrees Celsius and pressures up to 40 bar. For standard water systems, cast iron provides a reliable baseline. When your system demands higher tensile strength and impact resistance, you step up to ductile iron. For extreme conditions, you specify specialized materials. Cast steel handles high-pressure applications, stainless steel resists corrosive environments, and bronze for specialized fluid systems. This chart shows how material selection acts as your primary cost driver, followed closely by valve size. Moving from cast iron for standard water systems up to stainless steel for extreme conditions, the manufacturing complexity and the price both significantly increase. Precision in selecting these materials protects your budget. Specifying a higher grade than necessary wastes capital, while underspeccing your material invites premature corrosion. Step 4 focuses on procurement. A perfect technical specification sheet will not protect your system if the chosen factory cuts corners on the assembly line. Check 1 on your vetting list. The supplier must provide documentation proving they use exact materials rated for your fluid. Check 2. They must verify their designs conform to EN or API technical standards. For check 3, verify that the factory can match your exact pipeline diameter from DN15 up to DN600 and beyond. They must also be able to supply your specific actuation requirement, whether you need manual hand wheels, electric motors, or pneumatic actuators. Finally, check 4 requires the supplier to demonstrate an established track record of quality control, along with reliable ships such as sea freight or delivered duty paid, without hidden customs delays. By enforcing this strict evaluation protocol, you filter out substandard suppliers and secure an accountable supply chain partner. You now have a complete, fully realized profile. You know your internal gate type, your required stem configuration, your exact body materials, and you have a concrete vetting plan. The immediate next step for your procurement team is to attach these exact parameters to your official request for quote. Valverno is an experienced industrial valve manufacturer in China that reliably meets all the criteria on this vetting checklist. Contact Valverno's technical sales team today to validate your newly built spec sheet, and confirm global delivery times for your next project. When you standardize both your technical requirements and your supplier vetting process, you secure your pipelines, protect your purchasing budget, and guarantee long-term operational uptime.